According to the National Electrical Code, in a transfer switch application where multiple sources are connected, the equipment grounding conductors from each source must be isolated from each other. Isolating the equipment grounding conductors ensures that ground faults in one system do not affect the other system. This prevents dangerous ground loops and potential shocks. In a multiple source system, each source must have its own dedicated current return path through its own equipment grounding conductor. Bonding the equipment grounding conductors together would create a parallel path for fault currents, which can overload the equipment grounding conductors and create a fire hazard. To power the well from both houses safely and in compliance with the National Electrical Code, the following design should be implemented. Firstly, each source, house 1 and house 2, must have its own dedicated equipment grounding conductor. Secondly, each house should have its own separate grounding system, electrodes, ground rods, and so on. Thirdly, the transfer switch must isolate the equipment grounding conductors of both sources. This can be achieved using a transfer switch with separate equipment grounding conductor terminals for each source. Bonding the equipment grounding conductors of multiple sources in a transfer switch application is prohibited by the National Electrical Code and presents electrical hazards. Isolating the equipment grounding conductors ensures proper electrical isolation, current return path, and compliance with electrical codes. When working with electricity, it is always essential to consult the latest edition of the National Electrical Code and to seek the advice of a qualified electrician. The National Electrical Code Article 250 covers grounding and bonding requirements. Article 250.20 addresses the general requirements for grounding of electrical systems. Article 250.24 covers grounding service supplied alternating current systems. Article 250.30 covers grounding separately derived alternating current systems. Article 250.50 details grounding electrode systems. Article 250.146 addresses equipment grounding and equipment bonding jumpers for separately derived alternating current systems. In a typical residential setting, the grounding electrode system consists of a ground rod, a metal underground water pipe, or a concrete encased electrode. The grounding electrode conductor connects the grounding electrode to the neutral busbar in the main service panel. The equipment grounding conductors provide a path for fault current to return to the source, tripping the circuit breaker off fuse and clearing the fault. Ground fault circuit interrupters, also known as GFCIs, are used in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. Ground fault circuit interrupters detect ground faults and quickly interrupt the circuit, preventing electric shock. When installing a transfer switch for a well pump, it is important to follow the manufacturer's instructions and all applicable electrical codes. The transfer switch should be properly sized for the load and should be installed in a readily accessible location. The wiring should be done by a qualified electrician and should be inspected to ensure that it meets all safety requirements. The equipment grounding conductor should be sized according to National Electrical Code Table 250.122. The size of the equipment grounding conductor depends on the size of the overcurrent protective device protecting the circuit. For example, if the circuit is protected by a 20 amp breaker, the equipment grounding conductor must be at least 12 American wire gauge copper. If the circuit is protected by a 30 amp breaker, the equipment grounding conductor must be at least 10 American wire gauge copper. If the circuit is protected by a 60 amp breaker, the equipment grounding conductor must be at least 8 American wire gauge copper. The equipment grounding conductor must be connected to the grounding electrode system at the service panel. The equipment grounding conductor must also be connected to the metal enclosure of the well pump and the transfer switch. When installing the grounding electrode system, it is important to drive the ground rod deep enough into the ground to ensure that it makes good contact with the earth. The ground rod should be driven at least 8 feet into the ground. If multiple ground rods are used, they should be spaced at least 6 feet apart. The resistance of the grounding electrode system should be measured to ensure that it is below 25 ohms. If the resistance is higher than 25 ohms, additional ground rods should be installed. The National Electrical Code also requires that all metal water piping systems be bonded to the grounding electrode system. This is to prevent the water pipes from becoming energized in the event of a ground fault. The bonding jumper should be sized according to National Electrical Code Table 250.66. The size of the bonding jumper depends on the size of the service entrance conductors. For example, if the service entrance conductors are 4/0 American wire gauge copper, the bonding jumper must be at least 2 American wire gauge copper. When working with electricity, it is important to always de-energize the circuit before working on it. Use a voltage tester to verify that the circuit is de-energized. Wear appropriate personal protective equipment, such as safety glasses and rubber gloves. If you are not comfortable working with electricity, hire a qualified electrician. The use of a transfer switch provides flexibility in powering the well pump from either of the two houses. However, the grounding considerations are critical for safety and code compliance. By isolating the equipment grounding conductors from each house, the risk of ground loops and potential shocks is minimized. Each house maintains its own independent grounding system, ensuring that fault currents are properly routed back to the source. The transfer switch acts as a point of isolation, preventing any interaction between the grounding systems of the two houses. This design approach aligns with the National Electrical Code requirements and promotes a safe and reliable installation. It is important to remember that electrical codes and regulations may vary depending on the local jurisdiction. Always consult with local authorities and qualified professionals to ensure that the installation meets all applicable requirements. Regular inspections and maintenance of the electrical system are also essential to ensure its continued safety and reliability. Proper grounding is a fundamental aspect of electrical safety. It provides a path for fault currents to flow back to the source, tripping the circuit breaker and preventing electrical shock. A well-designed grounding system also helps to minimize electromagnetic interference and improve the overall performance of electrical equipment. In addition to the equipment grounding conductor, the National Electrical Code also requires the use of a bonding jumper to connect the metal enclosures of electrical equipment. The bonding jumper provides a low impedance path for fault current, ensuring that the enclosure remains at ground potential. This helps to prevent electrical shock if someone comes into contact with the enclosure during a fault. The size of the bonding jumper is determined by the size of the circuit conductors. The National Electrical Code provides tables that specify the minimum size of the bonding jumper for various circuit conductor sizes. When installing electrical equipment, it is important to carefully follow the manufacturer's instructions and all applicable electrical codes. This will help to ensure that the equipment is installed safely and correctly. Regular inspections and maintenance of electrical equipment are also essential to ensure its continued safety and reliability. Electrical safety is a critical concern for homeowners and business owners alike. By following the National Electrical Code and taking appropriate safety precautions, you can help to protect yourself and others from electrical hazards. If you have any questions or concerns about electrical safety, consult with a qualified electrician. In the context of the well pump application, it's vital to understand the implications of connecting two separate electrical services to a single load. Without proper isolation, a ground fault in one house could potentially energize the grounding system of the other house, creating a hazardous situation. The transfer switch is designed to prevent this by physically isolating the two electrical systems. This ensures that each house's grounding system operates independently and that fault currents are properly contained within their respective system. The isolation of equipment grounding conductors is not merely a theoretical concept. It has practical implications for the safety and reliability of the electrical system. By preventing ground loops, it reduces the risk of unwanted currents flowing through the grounding system, which can cause overheating, equipment malfunction, and even fires. It's also important to consider the potential for voltage differences between the grounding systems of the two houses. These voltage differences can arise due to variations in soil conditions, the proximity of other electrical equipment, and other factors. By isolating the equipment grounding conductors, the transfer switch prevents these voltage differences from creating a hazardous situation. When selecting a transfer switch for this application, it's important to choose a model that is specifically designed for multiple source applications. The transfer switch should have separate terminals for the equipment grounding conductors of each source, and it should be clearly labeled to indicate which source is connected to which terminal. The transfer switch should also be rated for the voltage and current requirements of the well pump. It's important to consult with a qualified electrician to ensure that the transfer switch is properly sized and installed. In addition to the transfer switch, other components of the electrical system must also be properly grounded. This includes the well pump itself, the electrical conduit, and any other metal enclosures. The equipment grounding conductors should be securely connected to these components, and the connection should be protected from corrosion. Regular inspections of the grounding system are essential to ensure that it remains in good working condition. The connection should be checked for tightness and corrosion, and the grounding electrodes should be tested to ensure that they are providing adequate grounding. If any problems are detected, they should be corrected promptly. The information provided is intended for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician to ensure that your electrical system is safe and compliant with all applicable codes and regulations. The design and installation of a safe and reliable electrical system requires careful attention to detail and a thorough understanding of electrical principles. By following the guidelines outlined above, you can help to ensure that your well pump is powered safely and efficiently from both houses. Furthermore, it is good practice to label the transfer switch clearly, indicating which position corresponds to which house's power source and the off position. This will prevent confusion and ensure that the switch is operated correctly. Regular maintenance of the well pump and its associated electrical components is also important. This includes checking the pump's wiring, connections, and motor for any signs of wear or damage. It's also a good idea to have the well water tested periodically to ensure that it is safe for consumption. Remember that electricity can be dangerous, and it's always best to err on the side of caution. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. Electrical safety is not just a matter of complying with codes and regulations. It's also a matter of protecting yourself, your family, and your property from electrical hazards. By taking the necessary precautions, you can help to ensure that your electrical system is safe and reliable. In conclusion, when powering a well from two houses using a transfer switch, it's crucial to isolate the equipment grounding conductors from each source to prevent ground loops, potential shocks, and fire hazards. Each house must have its own dedicated equipment grounding conductor and separate grounding system. The transfer switch should be designed to isolate the equipment grounding conductors of both sources. Always consult with a qualified electrician and follow all applicable electrical codes to ensure a safe and compliant installation.